slow. Hello? Huh? Hello? 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 Huh?
মর্নিং স্যার।
হ্যাঁ ঠিক আছে, তুমি আমাকে 1 ঘন্টা পরে ফোন করো। Morning.
Good morning, sir.
Good morning. Good morning.
মর্নিং স্যার।
Okay, so how many are there? 6. Okay, so last class we are discussing this thing, right? FFT. Hello, do you have any doubt last class what we have discussed?
No, sir.
Last, no doubt, everything all right. Okay, then we'll start the next thing. Okay, so last class what I have said, that we have to compute endpoint DFT using FFT algorithm. That's what we are discussing. Now, in this algorithm, what is the advantage? That we could compute the DFT faster. DFT faster in the sense it requires lesser number of multiplication and addition that we are discussing. And also we have already discussed that as per the computational complexity, which I understand number of complex addition and number of complex multiplication, that will be less if the number of endpoint DFT, if n is reduced, then this computational complexity will be less. With this idea, we have tried to develop the algorithm so that we can compute the DFT with lesser value of n, that is lesser point DFT, then combine those results to compute higher point DFT. With this process, what we are planning that we will have a reduced computational complexity. With this, we have discussed last class, we have come to this expression, right? X of k, f1 of k, wn k, f2 of k. Here x of k is your endpoint DFT, f1 of k n by 2 point DFT, f2 of k n by 2 point DFT. In general, this is endpoint left hand side and right hand side is your n by 2 point DFT. And 2 n by 2 point DFT, if we can compute, then we will come to the endpoint DFT, right? Basically, I have to compute x of k. For example, this is a general case, endpoint DFT, and this is the relation between endpoint DFT and n by 2 point DFT, or this is the relation. Using this relation, we can combine two n by 2 point DFT to achieve endpoint DFT. Okay, so this is the equation. This is the equation by which you can do that. Now, if I say n equal to 8, n equal to 8 means, for example, if I say n equal to 8, this is a general expression, right? This expression is a general expression. this expression is a general expression, but if I take a specific case for n equal to 8, and if we apply for this expression, therefore my left hand side will be n by n point dft, that is called 8 point dft, and right hand side f1 of k and f2 of k, that will be 4 point dft, I suppose. Now n equal to 8 x of k, what I understand, x of k should have value x0 up to x7, right? But f1 of k, that is 4 point, this is also 4 point. Now x of 0 is f1 of 0, then w80 f2 of 0, and x of 1 is f1 of 1, w81 f2 of 1. This is all right because I have the value of f1 of k, so f1 of 0 1 and f1 of 1, f2 of 0, f2 of 1, these all are known to me. Therefore I can compute up to x of 3. If I write x of 3, that will be equal to f1 of 3 w8 to the power 3 f2 of 3, like that. Like that, if you compute x of 4, x of 4 means f1 of 4 w8 4 f2 of 4. If I write k equal to 4 here, then x of 4 equal to f1 of 4 wn4 f2 of 4, then w84. Now if I look at w84 equal to e power minus j 2 pi by 8 into 4. See, e power minus j 2 pi is your w, and if it is 8 divided by 8, if it is 4 multiplied by 4, so this will be equal to e power minus j pi. If it is e power minus j pi, then it will be cos pi plus j sin pi, that will be equal to minus 1. So w84 I can write minus 8 w80. W80 is essentially 1. I am writing w80. Okay. So this is w80. Now x of 5, what I can write, x of 5 means here in this expression f1 of 5 wn to the power 5 f2 of 5. So what I have written, this is f1 of where this one f1 of 1, basically it is f1 of 5, f1 of 5 equal to f1 of 1, f2 of 5, that is equal to f1 of 1, because 4 point dft is periodic with period 4, that is f1 of 4 is a 4 point dft, f2 of 4 or f2 of k rather, this is a 4 point dft. If they are 4 point dft, then they will be periodic with period 4. So f1 of 4 equal to f1 of 0, and f1 of 5 equal to f1 of 1, f2 of 5, that is equal to f1 or f2 of 1, like that. Now if I write x of 6, that will be f1 of 6 w86 f2 of 6, 6 means again 2 plus 4, since this is periodic with period 4, so this will be equal to f1 of 2 f2 of 2. Now if I calculate w85, so w85 means e to the power minus j 2 pi by 8 into 4 plus 1. Now e to the power minus j 2 pi by 8 into 4, that is essentially w84, and w84 is equal to minus 1. So this will be minus w8 to the power 1. Agreed?
Yes, sir.
Fine. Similarly, w86 if you look at, that will be equal to w84 into w82. So w84 equal to minus 1, we have already seen, because 6 equal to 4 plus 2. So w84 is equal to minus 1 and w82 will be there. So this will be w86 equal to minus w82. Similarly, w87, this will be equal to w84 into w83. So this will be minus of w83. So what I mean, that with the knowledge of 4 point DFT, I have obtained 8 point DFT. Right? This is an example. This is an example, corresponds to n by 2 n point DFT, n by 2 point DFT, n by 2 point DFT. Now, with this calculation, we have entered 4 point DFT, but still we don't want to compute in 4 point. I have to go even lesser number of points. So this is a general expression. This is a general expression between n point DFT and n by 2 point DFT. How n point DFT and n by 2 point DFT are related? This is the general equation that we have derived from using this equation. So this derivation is the important part of this algorithm. So this derivation is the important part of the algorithm. Next of the derivation we don't do, we will write iteratively in the knowledge of this expression. So we don't derive further. So this is the backbone of this algorithm, that how do I relate n point DFT to n by 2 point DFT. Okay, left hand side your n point DFT, right hand side n by 2 point DFT. And we have seen for a special case x equal to n equal to 8, we can compute 8 point DFT using 2 4 point DFT. Okay, now suppose n by 2 point DFT that I now develop or decimate n by 4 point DFT, right? So what I have to do, I have to write v11 of n, of n, which is equal to f1 of 2n, and v12 of n is f1 of 2n. Now let us look at this example again, this problem again. See what we have done. We have developed f1 of n, f1 of n, and f2 of n from x of 2n and x of 2n plus 1 using this equation. Now x of n, so f1 of n that is derived from x of 2n. Essentially this is basically x of n, means this x of 2n, this elements essentially belongs to x of n. Now x of 2n plus 1 there essentially belongs to x of n. So f1 and f2 are the two signal or two sequence which are derived from x of n. Now this x of n is essentially 8 point, or x of n is an n point, then f1 of n, if I write this n has to be n by 2 minus 1. So one thing we have to understand clearly now. Suppose the original signal is n point, right? Then when we are deriving in two part using odd even decimation, then new function that is developed, that value of n is n by 2 minus 1. Now from f1, if I now develop two more function to get 2 point, right? So 2 function means what will be this value? Suppose from f1 I am developing two function, one is v11 of n, another one is v12 of n. Now tell me what will be the value of n then?
n by 4 minus
1. N by 4 minus 1, correct. So if I now develop two function v11 of n and v12 of n from f1 of n, then that will be 0 to n by 4 minus 1. Similarly, from f2 of n, if I want to develop two function v21 of n and v22 of n, there also n will be 0 to n by 4 minus 1. Is it all right for everybody?
Yes.
Yes.
Yes, sir.
Fine. Now see, I have written v11 of n that is equal to f1 of 2n, and v12 of n is f1 of 2n plus 1. Hello, এখন আমি ক্লাসে আছি 11:30 পর। Okay, so v11 of n equal to f1 of 2n and v12 of n equal to f1 of 2n plus 1. These are the two more decimations. So in this step we are now developing n by 4 point DFT and trying to relate this with n by 2 point DFT. Previously what I have done, n point DFT I have tried to relate to n by 2 point DFT using the equation x of k, f1 of k plus wnk f2 of k. Using that equation we have derived a relation with n point DFT to n by 2 point DFT. Now I am trying to relate n by 2 point DFT using to n by 4 point DFT. Okay, so now this okay, so this will be a 2 লেখা আছে, এটা 4 হবে, ঠিক আছে? This will be 4, right?
Yes, sir.
এটা 4 হবে. Okay, similarly v12 of n, this will be f2 of 2n, f2 of 2n plus 1. Okay, now tell me here, in this expression we are having two things. This is n by 4 point n by 2 point dft. This is n by 2 point dft. Now how they are related? তাহলে x1 of k, x of k is f1 of k, wn k, f2 of k. Now if I come here, তাহলে f1 of k কি হবে? n by 2 point
V1 of
of
K
k,
or
that n by 4 point, এটা
V1
v1
of
W
K,
by
omega n,
N by
আচ্ছা।
2,
W n K,
হ্যাঁ
V2 to F2.
ঠিক আছে, এখানে কি ছিল?
N by 2K.
তাহলে এখানে ছিল n পয়েন্ট, এখানে ছিল n, তাই না? এখানে এটা n পয়েন্ট, তাহলে এখানে n ছিল, তাহলে ওটা যদি n বাই 2 হয়, ওটা যদি n বাই 2, এটা যদি n বাই 2 হয়, তাহলে এখানে আমি কি লিখবো?
ওটা N by 2 হবে।
বোঝা গেল? আচ্ছা,
হ্যাঁ
এখানে k এর ভ্যালুটা কত হবে বলো তো?
এখানে 0 to N by 2 minus 1.
n by 2 minus 1 কেন বলো তো? কারণ f1 having 4 ভ্যালু, f1 of 0, f1 of তাহলে 4 ভ্যালু মাইনাস n by 2 মানে যদি আমি 8টা যদি
হ্যাঁ।
एग्जांपल হিসেবে ধরি, তাহলে f1 এ 4টে, তাহলে এই n টা কিন্তু আমার n by 2 minus 1 হবে। হবে তো?
হ্যাঁ হ্যাঁ
আচ্ছা, আর এইটা এখানে ভুল লেখা আছে, এটা n by 4 হবে। ঠিক আছে, এটা n by 4 করে দেবো আমি পাঠানোর সময়। ঠিক আছে, এটা n by 4 হবে, কারণ এখানে তো দুটোই সিগন্যাল থাকবে, এখানে দুটো থাকবে। f2 থেকে f2 তে কটা সিগন্যাল আছে? f2 ইউ আর হ্যাভিং 4 সিগন্যাল, তাহলে f2 থেকে আমি দুটো বার করছি, v21 and v22, তাহলে আমার দুটো দুটো করে থাকবে, দুটো করে থাকা মানে 0 আর 1 দুটো ভ্যালু হবে। তাহলে n by 4 করলে হচ্ছে 2 minus 1 হচ্ছে 1, তাহলে এটা n by 4 হবে। এটা আমি ভুল লেখা আছে, এটা n by 2 গুলো n by 4 করে দেবো আমি। বোঝা গেল জিনিসটা? Is it clear? Fine. Now similarly f1 of k equal to v11 of k, wn by 2k, v12 of k. Similarly f2 of k, what I can write? v21 of k, wn by 2k, v22 of k. But this k will be 0 to n by 2 minus 1. Now v11 of k is how many point dft? Suppose n equal to 8. If n equal to 8, v11 of k is
2 point
2 point.
2 point
তাহলে v11 of k যদি 2 point হয়, v12 k 2 point dft, v21 of k that is also 2 point dft, and that is also 2 point dft. Now these are the two equations which relates n by 2 point dft with n by 4 point dft. This is n by 2 point dft, this is n by 4 point dft. Now how that could be computed? How that could be computed means v11 of k, v12 of k, v21 of k, and v22 of k all are periodic with period
N by 4.
N by N by
n equal to 8. What is the value?
2.
8 2.
2.
তাহলে v11 of k, v12 of k, v21 of k, v22 of k, they are all periodic with period 2.
N by 4.
N by 4 or 2. In general, it is n by 4. For a particular case n equal to 8, this will be 2. Okay, this is in general expression. Okay. Okay. Now I'm writing, say f1 of 0. f1 of 0 is how much? v11 of 0. Then w n by 2 means 4. For specific example n equal to 8. Right? Example n equal to 8. Example n equal to 8 means I have to write here k will be 0, first value, say f1 of 0, right? This k will be varying how much? 0 to
3
correct.
3.
This k will be varying 0 to 3. So f1 of 0 is v11 of 0, w40 n equal to 8, w40 v12 of 0. Well, f1 of 1 is equal to v11 of 1, w41 v12 of 1. Then f1 of 2 is v11 of 2, w42 minus v12 of 2. Now v12 of 2 is again v11 of 0 because it is periodic with period 2. And w42, if you look at, this is minus 1. I am writing minus w40. W40 equal to 1. Agreed?
Yes, sir.
Good. Now f1 of 3 equal to v11 of 3 plus w43 v12 of 3. Now v11 of 3 equal to v11 of 1 because v11 of 3 or v11 of k, that is periodic with period 2. If it is periodic with period 2, then v11 of 3 equal to v11 of 1. Okay. And v12 of 3, that will be equal to v12 of 1. Okay. Now v11 and v12, they are the two signals or two sequence that is derived from f1 of n. Agreed?
Yes.
v11 of n and v12 of n are the two signals, they are developed from f1 of n. Okay. Now from f2 of n, we have developed two signal, one is v21 of n and v22 of n. Similarly, f2 of 0, that will be equal to v21 of 0 and v22 of 0 using this equation. Using this equation, again f2 of 1, that is equal to v21 of 1, v21 of 1 and w41, v22 of 1, v22 of 1. Then if I write f2 of 2, then this will be v21 of 2, w42 into this, and w42 again I have said this is equal to -1, so I am written minus w40. Then f2 of 3, f2 of 3 equation, this is v21 of 3 and w43 into v22 of 1. Now w43 equal to, you know, e to the power minus j2 pi by 4 into 2 plus 1. So e to the power minus j pi 4 into 2, that is equal to -1, and e to the power minus j2 pi by 4 into 1, that is equal to w41. So this will be minus of w41, that is equal to w43. Agreed?
Yes.
Fine. So if it is so, then I am writing that f2 of 2, that is equal to w4 v21 of 0 minus w40 minus w40, this equation, right? Because w42 equal to -1, so I am written minus w40. Okay. Now v21 of f2 of 3, f2 of 3, if you look at here, f2 of 3, v21 of 3, w43, v22 of 3. v22 of 3, v22 of 3 is equal to v22 of 1 because this is periodic with period 2, and v21 of 2 equal to v21 of 1 because this is periodic with period 2. So like that we have computed f0, f1, f2 and f3. Okay. Now for the specific example, for this specific example, right, now if you look at this equation, so I have computed, suppose n equal to 8. So this is your n by 4 point DFT. This is your n by 2 point DFT.
N by 2 point.
By 2 point DFT. So what I mean, it is 4 point DFT. 4 point. If n equal to 8. If n equal to 8, this is f1 of k and f2 of k, they are 4 point DFT, right? And these are v11 of k and v12 of k, v21 of k, v22 of k, they are 2 point DFT.
2 point DFT.
Tale, what is there? This is 2 point DFT. I have computed this 4 DFT. Suppose say I am computing v11 of k, v12 of k, v21 of k, v22 of k. They are essentially all 2 point DFT for a specific case of n equal to 8. Agreed? I repeat,
Yes,
v11 of k, v12 of k, v21 of k, v22 of k, they are all 4 by 2, that is 2 point DFT, right? They are all 2 point DFT. Now these 2 point DFT I have combined. I have got two 4 point DFT. I have combined, this is 2 point DFT, this is 2 point DFT, that is v11 of k, v12 of k. I have combined them. I have got 4 point DFT. And v22 of k and v21 of k, if I compute, I will get f2 of k is equal to a 4 point DFT. Agreed? Now,
Yes, sir.
so once I calculate 2 point, 2 point, 2 point, 2 point, 4, 2 point, I have got 4 point. Now, if I use this equation, then this 4 point, 4 point, if I combine, I will get 2 point, 8 point. Agreed?
Yes, sir.
Therefore,
Yes.
so what I have to compute? I need not compute 8-point DFT anymore. I can compute 4 number of 2-point DFT. 4 number of 2-point DFT, which is essentially V11 of K, V12 of K, V21 of K, and V22 of K. These 2-point DFT I will compute. 4 number of 2-point DFTs. I repeat, I am computing 4 number of 2-point DFTs, like V11 of K, V12 of K, V21 of K, and V22 of K. 4 number of 2-point DFTs. If I combine, I will get 4-point DFT. Once 4-point DFT result is available to me, I can combine them. I can get 8-point DFT. Agreed?
Yes.
So, compute DFT, 8-point DFT, I no more require to compute 8-point. I can combine them if I compute only 2-point DFT. Okay. Now, next thing that we have to identify, that I have to compute V11 of K. That I have to do. I have to compute V12 of K. Now, V11 of K or V12 of K or V21 of K, V22 of K, if I want to compute, I have to know what? What I have to know? To compute V11 of K, what I have to know? I have to know V11 of N. I have to know V12 of N. I have to know V21 of N. I have to know V22 of N. That I have to know. Unless we know this, I cannot compute. Right? Now we'll try to know that. I have so far is all right. Any doubt if you have? No doubt.
No.
Very good. Very good. So at this stage, what I have said, that is written here, that x of 8 is 8-point sequence, they are 4-point sequence, they are all 2-point sequence, that is written here. Now I'm trying to find that V11 of 0. V11 of 0, where is V11 of 0? Let us come here. That V11 of 0, that is equal to F1 of 0.
Yes.
F1 of 0, F1 of 0, F1 of 0. What is F1 of 0?
X of 0.
তাহলে V11 of 0 টা কত হবে?
X of 0.
X of 0. Now V11 of 1 তাহলে কত হবে? F1 of 1. V1, আচ্ছা V11 of n এ কটা পয়েন্ট থাকবে?
কি স্যার?
A1.
V11 of n, how many points should be there? V11 of n?
2
2 point. 2 point. Because
Yes, sir.
V11 of K is the 2-point DFT. The maximum number of points in V11 of n is 2. Because length is less than or equal to n. I have said earlier. So V11 of n can contain at most 2 non-zero value or 2 signal values, 2 sequence values. Because my V11 of K is a 2-point DFT. The length of the input signal less than or equal to n. N is the number of samples. What I said already. Therefore, V11 of 0, which is equal to F1 of 0, that is x of 2, and x of 0, and V11 of 1 equal to V1 V11 of 1. V11 of 1 means
F of 2.
F1 of
F2.
2.
F1 of 2. F1 of 2 মানে
X4.
x4. তাহলে
X4. X4.
হ্যাঁ, তাহলে V11 of n পয়েন্ট গুলো কি হয়ে গেল? x0
0
আর X4.
x0 x0 and x4
X4.
দুটো। তাহলে V11 of n is x0 and x4. Are you convinced? Is it all right?
Yes.
Yes?
Yes.
Fine. Now tell me what is V12 of n? V12 of n. V12 of n. V12 of n is V12 of n 0. কত হবে? V12 of 0?
F1.
F1 of
F1 of 1. তাহলে F1 of 1 কত হবে?
X2. X2.
X2. Correct? Okay. Now V11 or V12 of 1 কত হবে?
F what sir? F1 of 3.
F1 of 5.
3
না, F1 of 3.
F1 of 3 হবে।
F1 of 3 মানে F1 of 3
X of
V12
6
তাহলে V12 of 1 হচ্ছে F1 of 3, F1 of 3 মানে x of 6, তাহলে আমি কি বার করলাম V11 of n equal to x of 0, V11 of n that will be x0 x4 and V12 of n that will be x
X2 X6
হলো। এবার বলো দেখি V21 of 0
V
21 of 0
কি বল
V21 of 0 কত হবে?
V2
2 F21
0.
F2
V21 of
X3
x3 হবে
yes
হবে তো, আর V21 of 1
F2 of
F2 of 2 F2 of 3 F2 of 3
F6
মানে X7
X6
আচ্ছা, আর V22 of 2 V22 of 0
F2 of 1.
F2 of 1 F1 means
1 মানে 3 X3
F2 of 1 মানে হচ্ছে X3
x3। আচ্ছা এখানে চলে এসো, তাহলে F2 of 1 মানে x3, ওকে। V22 of 1
V22 of 1
F2 3
হ্যাঁ
তাহলে x7 হয়ে গেল,
yes sir
হলো। আচ্ছা আরেকবার বলো দেখি V21 of 0 টা কত হয়েছিল দেখো তো, V21 of 0
0 মানে F21
F21 মানে হচ্ছে
X3
X3
দেখি আগে V21 টা
V21 তাই গেল
V21 হচ্ছে F2 of V21
N
V21 0 V21 of 0 মানে কত, F2 of
F2 0 মানে X1
হলো, আর V21 of 1 মানে F2 of
F of 2
F2 2
F2 of 2 মানে
2 মানে X5
X5
হলো। তাহলে what we have obtained finally that if I write here, is it all right? V11 of 0 and V11 of 1, that is x0 x4, V12 of 0 x2, V12 of this x6, then this is x1, this is x5, and V22 of 0 x3, V22 of 1 is x7. Is it all right?
yes
Anybody having doubt, and it is all right? Huh? It's all right?
yes
If you have any doubt, you can ask. I have no doubt. Therefore, I have to compute V11 of k. V11 of k. K will vary from 0 to 0 to 1. 0 to 1. K bollo 1. Correct. So V11 of 0 or V11 of 1, this is time domain I know, but I have to compute V11 of k, V12 of k. Now once I know V11 of n, V12 of n, V21 of n, and V22 of n, this V11 of n, V12 of n, V21 of n, and V22 of n, these all are 2-point sequence. So I can easily compute 2-point DFT. Once I compute 2-point DFT, now x0 x4 will be some value, right? X0 x4 some value, x2 will be some signal value, this x6 will be some signal value. Now I have to isolate these values, then I using these two x0 x4, these two value I have to compute 2-point DFT, x2 x6 I have to compute 2-point DFT, x1 x3 5 I have to compute 2-point DFT, x3 x5 I have to compute 2-point DFT. Okay, now the problem is how could you remember 0 with 4, 2 with 6, 1 with 5, 3 with 7, right? So entire derivation what I have given. Now this derivation is required for understanding the thing, and this derivation is required for writing short notes if short note comes on FFT. Right. For problem solving, this derivation is not required. Only you have to know the equations. Okay. Now I'll tell you how to remember this 0, 4. Now generally you have to take x0, x4, x2, x6, x1, x5, x3, x7. Right? This you have to take combination. How to remember? Now how could you write 0, 1, 2, 3 in digital? 0, 1, 2, 3, 4, 5, 6, 7. Here will it be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and this is 1, 1, 1. Now, if you write the bit in reverse order, how do you write? 0, 0, 0, it will remain same. 1, 0, 0, it will be 1, 0, 0. 0, 1, 0, it will be same, like this. 0, 1, 1, if you write reverse order, that will be 1, 1, 0. Now 1, 0, 0, if you write reverse order, that will be 0, 0, 1. 1, 0, 1, if you write reverse order, it will remain same. 1, 1, 0, if you write reverse order, it will become 0, 1, 1. And 1, 1, 1, if you write reverse order, this will become 7. Now reverse order, if you read, this is 0, this is 4, this is 2, this is 6, this is 1, this is 5, this is 3, this is 7. All right. So you put one x before this, you write x0, x4, x2, x6, x1, x5, x3, x7. Like that, your order is. Have you got this?
Yes, sir.
So entire derivation, what we have done, that is only to learn the theory behind this. How things are developed, how FFT algorithm is developed. That is what we have derived. And after derivation, I came to know that I have to take x0 with x4. I have to take x2 with x6. And x1 with x5, x3 with x7. Then how do you remember this? The remember means if you write 0, 1, then you make the reverse order, then you take the combination from the beginning. 0, 4, 2, 6, 1, 5, 3, 7. Okay. So this is what the algorithm is. Now one thing we understood from this algorithm, that if I am asked, if I have to compute n-point DFT, right, n equal to say 8, then I don't compute. I will compute first 2-point DFT. I will combine this result, then I will get 4-point DFT. I will combine the results of 4-point DFT, I will get 8-point DFT. Now suppose you are supposed to compute 16-point DFT, then you have to compute first 2 point, then go to 4 point, then go to 8 point, then you have to go to iteratively 16 point. So what I have derived essentially how n-point DFT, n by 2-point DFT, n by 4-point DFT, what is the relation, right? Now f is large. If n is large, then you have to go n by 8, n by 2, n by 4 may not be giving you the value 2. So we will compute DFT when we are having n equal to 2. Before that, we don't compute. I will compute only at n equal to 2 and keep on combining the result to get the higher point DFT. And from the expression of computational complexity, I can say that since I am computing at lower level n equal to 2, then definitely it will be having reduced computational complexity. But the question is, after this algorithm, what is the computational complexity? That I will take in the next class, because I am having only 1 minute left, 1 minute 20 seconds. So what I have understood so far, that yes, I have computed only 2-point DFT, and combining those results, I can achieve up to 8-point DFT or even more. But the thing is that what exactly the computational complexity, that I will estimate in the next. Okay. With this, if you have any small doubt, you can ask, because I have less than 1 minute. If you have any doubt, you can ask. Any doubt if you have? Hello. Any doubt? If you have no doubt, then I have to stop. Thank you. Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Yes, sir.